An invisible atmospheric blade can slice through even the largest aircraft, manifesting suddenly from clear skies. This unseen force routinely shapes our weather, from gentle breezes to destructive supercell thunderstorms. Welcome to the intricate world of atmospheric science, where air itself performs astonishing, powerful feats. Today, we unravel the mystery of wind shear, a fundamental atmospheric phenomenon impacting our planet daily. Wind shear refers to a dramatic change in wind speed or direction over a short distance, either horizontally or vertically. Imagine different layers of air, like stacked plates, sliding past each other at varying velocities and trajectories. This difference creates immense friction and turbulence, generating powerful, often unperceivable, atmospheric scissors. Understanding wind shear is crucial because it significantly influences weather patterns and aviation safety worldwide. From a calm afternoon to a chaotic storm, wind shear often dictates the intensity and longevity of weather events. Pilots constantly monitor for its presence, as sudden changes can severely affect an aircraft's lift and control. Meteorologists actively track wind shear to predict severe weather development, especially the formation of dangerous tornadoes. This pervasive phenomenon exists everywhere in the atmosphere. It's most from the ground up to the impactful highest reaches of the manifestations, often stratosphere.
Yet, its most dramatic and impactful manifestations often occur much closer to Earth's surface, demanding our attention.
Slight wind shear generally goes unnoticed, but increased intensity drastically alters atmospheric stability and dynamics. This intricate dance of moving air layers sets the stage for some of Earth's most spectacular and dangerous weather. So, how exactly does this powerful atmospheric shearing mechanism come into existence and exert its influence? Wind shear primarily forms due to variations in atmospheric pressure, temperature, and terrain features across regions. One common type, horizontal wind shear, involves changes in wind speed or direction over a geographical area. Think of a strong cold front advancing, where cold, dense air pushes against warmer, lighter air, creating a boundary. Along this boundary, winds on one side might blow southwest, while winds on the other side surge from the northwest. This abrupt directional shift generates a horizontal shearing motion, often producing swirling eddies or even mesocyclones.
But that's not the only way this atmospheric force operates. Vertical wind shear presents an even more profound challenge.
Vertical shear occurs when wind speed or direction changes significantly with altitude, creating distinct atmospheric layers. A classic example is a low-level jet, presents an even more ribbon of fast, profound-moving air challenge, developing just above the surface, beneath slower winds. This intense vertical gradient in wind speed can literally tilt and stretch rising air parcels within developing storms. Imagine a tall, narrow column of air rising, then suddenly encountering winds blowing much faster or from a different direction. The top of the column gets pushed sideways while the bottom lags, creating a rotating motion through the storm's core. This tilting is absolutely crucial for the formation and sustenance of supercell thunderstorms, Earth's most powerful storms, and the consequences are far greater than you might initially imagine. Without sufficient vertical wind shear, a thunderstorm's updraft would remain upright, quickly collapsing under its own rain. The rain would fall directly back into the updraft, choking off the storm's energy supply and causing it to dissipate.
But with strong shear, the updraft becomes tilted, separating the rising air from the falling precipitation shaft. This ingenious atmospheric separation allows the updraft to persist and intensify, drawing in more warm, moist air continuously.
Separating the continuously rising air from the falling precipitation shaft, dangerous localized columns of sinking air. These microbursts can produce extremely powerful, outward-spreading winds upon impact, posing an immense threat to aviation. Airplanes encountering a microburst can experience a sudden headwind, then a downdraft, followed by a severe tailwind. This sequence drastically reduces lift and can cause an aircraft to lose altitude rapidly, even during landing or takeoff. You won't believe how this invisible force impacts our daily lives and global systems. Furthermore, wind shear near mountain ranges occurs as air flows over complex terrain, creating turbulent, unpredictable currents. These mechanical disturbances generate standing waves and rotors, significantly impacting flight paths and local weather conditions. Where vast speed differences exist between the core and its edges, destructive shear arises from strong wind shear at high altitudes, particularly near jet streams.
Jet streams are narrow bands of extremely fast-moving air, where vast speed differences exist between the core and its edges. This differential flow generates immense friction, creating pockets of violent turbulence that can unexpectedly jolt aircraft. And then something unexpected happened. Even seemingly benign weather conditions can harbor hidden, destructive shear.
Temperature inversions, where warmer air sits above cooler air, can also trap wind shear close to the ground. This low-level shear becomes particularly dangerous for aircraft during takeoff and landing, where maneuverability is critical. Coastal areas frequently experience sea breezes that interact with prevailing winds, establishing localized, strong shear zones. These boundaries, called convergent zones, often trigger localized thunderstorms or enhance existing atmospheric instability. The atmosphere constantly strives for equilibrium, but these differences in wind vectors create intricate, dynamic interactions. The real-world implications of wind shear extend far beyond mere atmospheric curiosity, touching lives and livelihoods. For aviation, accurate wind shear detection and avoidance are paramount for ensuring the safety of millions of passengers.
Advanced Doppler radar systems now precisely map wind velocity changes, providing crucial, real-time data to air traffic controllers.
These systems help pilots navigate around dangerous shear zones. Lives annually. Accident beyond and aviation. Real-time data to air traffic controllers. Its presence transforms ordinary thunderstorms into long-lived supercells, which spawn the most destructive tornadoes on Earth. The rotating updrafts generated by vertical shear are the very birthplace of mesocyclones, the precursors to powerful twisters. Without this atmospheric shearing, the raw energy of a thunderstorm would never coalesce into such devastating, concentrated power. This phenomenon means that understanding wind shear empowers communities to better prepare for and respond to extreme weather. Meteorologists rely on complex numerical models, incorporating shear data to issue tornado watches and warnings with greater accuracy. Farmers and agricultural planners also consider wind shear effects, especially concerning crop damage from severe storms. Its atmosphere's inherent influence, even complexity, and its capacity for extends to both subtle beauty and renewable energy, is destructive force, significantly affected by varying wind profiles.
Engineers must design turbines capable of withstanding the immense stress caused by sudden, dramatic changes in wind speed. Thus, wind shear is not just a scientific concept, it is a critical factor influencing infrastructure, safety, and economy.
Its atmosphere's inherent influence, even complexity, and its capacity for extends to both subtle beauty and renewable energy overwhelming, is destructive force. This omnipresent force continually reminds us of our planet's dynamic systems and the constant need for scientific understanding. Every gust, every swirling cloud, every powerful storm carries the signature of this fundamental atmospheric scissor at work. Recognizing its pervasive role allows us to better predict, prepare for, and ultimately respect our dynamic weather environment. Ultimately, wind shear stands as a testament to the atmosphere's incredible power, a silent architect of our world's weather. If you found this explanation fascinating, subscribe for more incredible stories and insights into our amazing planet. Let me know in the comments what other atmospheric phenomena truly captivate your curiosity and imagination.